Okay guys, welcome to today's session, our series of Gen AI, the concept of convolution neural network. In the yesterday's session, we started the discussion of convolution neural network with the very basic concept of image representation. How the color images will be represented and the grayscale images will be represented. And in order to work with the image data before sending this data to the neural networks or machine learning algorithm, we need to pre-process the data and make the data ready for the neural network algorithm. The primary and most important data structure when you are working with the torch framework is torch tensors. So the basic transformation you are supposed to apply on the image data. The very first step of pre-processing is converting into the torch tensors. Along with the tensors we had applied, we learned different few more transformations: grayscaling, resizing, okay. And if you are applying a sequence of transformations to an image, it is convenient to define all those transformations in a beautiful library method that is called transforms method, that is called compose. So it will create a pipe of transformations that you wanted to apply to an image. After defining all this pipeline of transformations, simply passing the image to this particular already opened or read images to this particular transformation variable, all the sequence of transformation will be applied one after another. This is the part we had finished in the last session. Okay, there I forgot to say one important point, I am just showing this one, you can do that one. So these are the informations we have done, do you remember? Right? So before converting, I will show you this from this point. Okay, when you work with the image data, look at here, this part we have done at the last. You no need to do this, it's a simple thing, we already done this part. I missed to tell one important point. So circle image, we worked on the circle image, converted into torch sensors and applied the transformations as well. At the very beginning of this images, I show you, if you displayed this image, what is this IMG? IMG is a variable once you read that image using the matplotlib library. This is a ND array, 3-dimensional array. When you display this array, what is the values that you could see? These are the pixel values, 255, 255 like this, because the pixel information is a range from 0 to 255. Got it? Once what I did is here, after that I had applied converting into the torch tensors and applied the transformations, and finally what is the image that I got? Resized image. If I displayed the resized image, what is the result? Will I get the same? Yes or no? We don't know. Let us see. This is the part that I missed to show you in the last session. Okay. The same I displayed here. You can see that print res message. What you got? Torch tensor, all the values are converted into scaled to the range 0 to 1. That is the beauty of the torch tensors. When you are working with the TensorFlow, during the first step of processing of image data, once the image is read into the NumPy array, the first step we are doing is normalizing, dividing the pixel values by 255 and scaling into the range of 0 to 1. That intentionally you are supposed to do is the first step in the pre-processing when you are working with the TensorFlow framework. So when you are working, if you are working with the PyTorch tensors, just by converting the image data to the tensors, it will automatically do the job. Scales this image data to the range of 0 to 1 by dividing each pixel value by 255. You don't need to do it additionally. That's it. Okay. Let's back, all of you keep open today's session where we stopped in the yesterday class. You just recollect it here. We started the discussion of working with the directory of the images. Initially I told you how to work with a single image. Now I am taking you to the concept of next level bulk of images, directory of images, right. All of you logged in? Keep open the same session 1 practice notebook. How many of you already? Raise up the hands. Very less. Everyone need to do this. Okay, right. So we are working with animated faces. This is the shared drive location which is provided to you, and if you list it ls, what you can see? Okay, let me list first the anim faces only. I am just revising only this particular step. It is consisting of 2 subfolders, glasses and no glasses. Okay, anim faces is the main folder, root directory. When I listed, it is consisting of 2 subfolders. Let me have a look on what is there in each of these one. Glasses. You can find a number of JPG images within the subfolder glasses, right? How many images are there? 3 rows, 5 into 3, 15 images. Fine. And I am having another subclass that is no glasses. Let me look into that also. 15 more images. What does it mean? The data is organized. How the data is organized? Correct? Anim faces is the main directory consisting of 2 subdirectories, glasses and no glasses. Each is consisting of 1 to 15 image and 15 more images. What does it mean? Directory with the subdirectory names are nothing but the labels of the images. Each subdirectory consisting of the samples belonging to that particular class. So such data set is useful. This data set is well organized for the task of image classification, right. Now the point of discussion is, if you have the data structures in a such well organized way of folder and subfolders which are related to the classes of the data set, then there is a beautiful module that you can use, that is called datasets.image folder. Image folder is a library module that you can use for loading the images which are organized in a proper way with the subfolders as the related to the labels. My data structure which I have chosen, data directory, anim faces, is in such a way it was organized. So I can use it. What are the key features of using, the benefits of using this image folder is best suitable for the subdirectories of the data structure which are nothing but the labels, and it will automatically applies the transformations if provided, optional transformations. When you are creating a data set using the image folder, if you provide the transformations to be applied, it will apply automatically. In such a way it was defined, right. Let us moving on to this one. Okay, this is what we did it in the. And the first step, datasets.image folder is supposed to be, and you need to pass this data directory anim faces and storing it to the variable called the dataset. In order to use this image folder, I suppose to import the required library datasets which is provided in the Torch Vision. So from Torch Vision, first of all import the datasets. Okay. From datasets, with respect to datasets, call the image folder and create the dataset. This part is done. See, if you run this code cell, what you can see? There are 30 data points in this image, in this directory. What does it mean? I had shown you 2 subfolders with glasses and no glasses, each is consisting of 15 images. Collectively together, there are 30 data points in this data set. What is this data set? If you want to see, call the attribute samples. So what you can see from here? Look at here. It is a list of what? Tuples. So data set is iterable, which is consisting of list of tuples. What each tuple is consisting of? You can see this comma, separated by comma. First is the image, this something dot jpg, along with the complete path from the root directory, followed by its label, data and output, data and label, input and output, pair information. Okay, done with this. If you want to see what are the classes, of course I had already shown you by listing the directory name, but from the dataset I am showing you. Dot classes attribute will give you the what are the classes in this dataset. If you want to see the classes with respect to the corresponding indices, you can use attribute class to idx. Is it visible to you all at last? Yes or no? Right. How many of you reached to this point? Raise up the hands. What are you doing at last sitters? Only 6 or 7 members only. Okay, I will wait for 1 minute to reach this point. Whomever are absentees of the last session, you have been given in the notebook itself, in the first code cell, you have been given path to the sample images along with the path to a sample directory. Now we reach to the point of discussion of the directory. So from directory do this part, create the data set using the image folder, using the image folder class from the Torch Vision library, imported from the Torch Vision datasets, and just display the dataset so that you can get the output. That is the dataset consisting of 30 data points, because that was the folder which consisting of 2 subfolders, each with 15 images. So a total of 30 images you would get, and just use the 3 attributes: samples, dataset.samples, dataset.classes, dataset.class to idx. Okay, fine. Thank you. Make it fast, guys. I need to move forward. See, remember the thing again, I am telling you. We are doing the coding, we will write all the entire step or copy and pasting it here, and we will do complete this. But we do not know why we are doing that particular, function or command and all these things. I am trying to make and learn, I am trying to make you to learn that basic information, that basic things which are required for you. Sure, I am telling you, if you do this task and finish off this task and exercises, you feel happy, you enjoy the learning. So do focus on it. Now will you raise up the hand? How many of you completed? Reach it to this point? Same is the number. Okay. Now the thing is, task is, create, train and test data sets with 13 images of each class into train and the rest into test sets. Will you try to understand this? Now I had a huge data set of 30 data points with me. What is my intention and job? Train and test data sets with 13 images of each class into train and the rest into test. Clear? How many classes I am having? 2 classes. That I can show it from the dataset.classes. 2 classes I am having. For each of this class, I need 13 images of into the train and the remaining into the test set. Clear? This is what I need to do. In such a way I want to train my model. Right. How can I do this? So what I need? Indexes of these data points which are there in the data set. I just created data set, it is there in the variable data set. From the data set, with respect to each class, I need the data indexes, right? How will I get the data from the data set? From dataset.samples, which is iterable, correct? So, from the dataset.samples, I can get the actual data. So, what I am doing is, now because it is an iterable object, I need to enumerate it, explore it. So, that is what I am doing. For image comma label, what I am getting? I had already shown you a pair, a tuple of image and label. Image comma label in enumerate of dataset dot samples. If I display, I am trying to display first image and label. Am I getting that? Individual images and the labels. Along with this tuple, you can see something, one more information prior to this one. What is this? 0, 1, 2 and so on. 29. What are these? Indices of the data points. That what I need first. So, I am using one iterable variable to get that along with this I comma, instead of image and label, I wanted to print this I. Yes, I got the indices. Able to catch me and follow me? My data set is iterable object. I am enumerating it in order to get the indices of the data points, right? Okay. Now, what is our task? With respect to each class, I need the indices, not all the indices. Now, I am getting all the indices 1 to 29. But what I want? With respect to each class separately. How can I do this? If I apply the logic here, if this label what I am extracting here by enumerating this data iterable object, if this label is 1, if I display this information, what I am getting? Indices of the class 1, nothing but animated faces with no glasses. If I change it to the 0, what I would get? First 15 images which are of the glass, animated faces wearing the glasses. Clear? So, with this logic you are able to separate, are able to get the data indices related to each label or each category of the data samples. Instead of printing, what I am telling you, to do this, you just display it or list it. List I for I in the range if label equal to 1 or label equal to 0, and put it into the, store into the variable class indices equal to, and display the class indices. Right? If I change this value 0, label is 0, I would get the indices of the another class. You understood this logic? Okay. Now, I want to put this logic in a for loop across all the samples. How many labels are there for me, class labels? 2. Okay. How can you fix this? You can't give the static number 2. Number of classes in the data sets. Across the length of dataset dot classes, you are supposed to do it. So, put it in the for loop. For class IDX in range of length of dataset dot classes, create this list. What changes I should make here? Can you tell me? Here label equal to, label equal to class ID. Yes, very good. You understood this logic? How I wrote? This is the way you are supposed to write the logic to extract, not from the for I equal to. You should go in a reverse engineering process. You should destruct the concept, then only you can learn it. Fine. Now let me display the class indices by print command. What should I get? Can you guess? Anyone? To list, exactly, correct. This is what I need. Am I correct? For the first class IDX is 0, you will get one sublist, 0 to the image data points from 0 to 14, first 15 images of glass category. Next, no glass category. Now I got the indices. My indices related to each class separately I am having in the class indices variable. From this class indices, what I need now to finish up this task? First 13 into train indices, rest into test indices. Okay, tell me what I supposed to write here instead of printing. Train indices equal to, can I? Okay, train indices equal to class indices of slicing up to 13. Am I correct? What is the mistake there? Nothing. Okay. Similarly, test indices equal to, from the class indices, take the rest 13 onwards. Okay, I did this job and I am trying to print train indices and test indices. I did the mistake somewhere. Train indices is not defined. Spelling mistake. Can you see this? Now tell me where I did the mistake. Okay, I am getting only the second class level information. What change is needed? Append. So here itself in the for loop I should not create the list. I have to initialize the list and update the list. Yes, he is guiding me in such a way. So first thing, let me initialize this train indices equal to empty list, test indices equal to empty list. Okay, now I need to update the test indices. What should I do, mister? Append. I initialized the list with empty. Now I should append it. Correct? Yes or no? Somebody tell me. Yes. Thank you. Append this class indices up to the 13 and similarly test indices append with the class indices 13 onwards. Okay? Sorry? Okay. You are getting the result. No problem here. But the thing is, list of sublists is being created. Do you have any problem with this? No? Very good. Any problem with this? What is the problem? Okay, let us see. In future, if you are getting the problem, we will back and we will resolve this issue. Fine? Sorry? Any problem with this? No problem. Very good. So, I created the train and test indices. You can see that 0 to 12 and 15 to this, what is this? Where can I see this information? Let me zoom out a little bit for seeing this. Okay. Up to 27, you can see here 0 to 12 and 15 to 27 into the train. This is one list, which is a list of sublist, and 13 to 2. Okay, I'll make it very clear, so to avoid the confusion. Train indices. Now can you see? Train indices is a list of sublist. Anyhow, I am getting all the indices, but list of sublist. Test indices, I am getting the required indices. Last two from the glass class and the last two from the no glass class. I am getting clearly 13, 14 and 28, 29, no problem. Okay, let me proceed that. So instead of printing, what I am doing is, yes, up to this part is clear. I got the train and test indices. What is the next step? Data set is to be created. So the step is creating train and test data sets. So let me take the two variables, train data set and test data set. Okay, tell me how to create the train and test data set. Already I had the data set, I have the train indices. Passing with respect to train indices, I need to get the subset from the main data set. Is it clear? Okay. For this, you supposed to use the torch.utilities.data, utils.data.subset is the method supposed to be called. S is capital. Is it visible? I'll zoom a little bit. Okay. Torch.utilities.data.subset is supposed to be called by passing the entire data set and the train indices. Now I can create a subset of the entire data set with respect to the train indices passed. This is the train data set will get created. Similarly, create the test data set. Torch.utilities.data.subset of entire data set and test indices. Okay, done. Let me display the length of train and test data sets. Sir. Yes. In order to use the torch, I am supposed to impose torch library. Data set spelling. Can you see here what is the output I got? What is the output I got? What is the size of the train data set I got? 2. Test data set 2. But what actually your expectation? 13 and 4. Sorry, not 13. 13 plus 13. From two classes, 13 plus 26 and 4. Is it clear to you? Now where is the mistake happened? Here the indices created were, yes, list of 2 sublists. So each sublist is considered as a single element and counted it as the 2. So what the change I supposed to made here? Instead of appending the list, I supposed to extend the list. Right. I am changing it now. Now, okay. Did I got? You understood? Now tell me what is the difference between append and extend. Append will append the entire list as a single element, but extend will iterate through that object and individually each element will be appended. Okay? Their object is a sublist. So extend will iterate through that simple list, individual inside list, and each element will be appended. That is the difference. So you understood what is supposed to be used there? Now I supposed to use this extend only. Got it? So I got my train and the test data sets. Now the thing is, what is there in the train data set? Let me show you some sample. What is there? I am taking one sample from the train data set. What is the image? It is a pill image which is of RGB mode and the size is 99 by 99. Okay, let me take another sample. What is the size? 112 by 112. Similarly, another image. So all the images in my data set are of different sizes. What the thing? What I supposed to do? Apply the transformation of resize, fixing to the fixed resize. Okay, where should I do this one? Apply the, okay, for your convenience I splitted the code. I am taking this part also into this part, this code cell. I just included the above code cell also into this part, nothing else. Okay, here I created the data set. So as I told you, when you are using image folder from the datasets module, you can apply the transformation here itself. So in order to apply the transformation, first let us define the transformations to be applied. Trans equal to transforms dot compose. This is what we did yesterday, and by passing the list of transformations with respect to this, you can do this. Transforms dot to tensor is the first transformation I wanted to apply, and transforms dot resize is another transformation I wanted to apply by specifying the size is 28 by 28. Two transformations I am thinking of to apply. So because I am using the transforms, I supposed to import the library from Torch Vision along with the data set transforms as well. From Torch Vision, import transforms, and now define the transformations that you wanted to apply using transforms.compose and list out all the transformations. One is the transforms.to tensor and second is transforms.resize. Just look at how I am writing. To tensor, T and T are capital. Transforms.resize, R is capital. Specifies the dimension of the resizer object within the resize. And check the spellings that you are using. Transforms. Because you are using compose is the method, C is capital. Whomever are absentees of yesterday, listen this. So for this I am importing the supporting library from the Torch Vision transforms. Am I clear? Okay. So after defining these transformations, whatever I wanted to apply and stored into the variable trans, now I can pass these transformations while creating the data set using the image folder object. So in the image folder along with the animated faces, this is the root directory. Now I am applying the transformations using the variable transform equal to, my transformations are trans. Remember that I am not giving you blindly the entire code. I am telling each and everything, what is the need and necessity. Got it? We define the transformations and stored into the variable trans, and the trans is passed to the image folder object when I am creating the data set with the variable transform. Please remember, here it is the transform, not plural. When you are defining the transformation, it is the transforms. Okay. No more changes I am doing. Do you remember why I am doing these transformations? Because I am getting the images of different shapes. I wanted to fix it and converting into the torch tensors. Done it. Now let me finish off this. Run the code cell and do it again. Can you see the difference? Earlier I got pill image. When I try to show what is there in the data set, I got pill image representation on object. Data set is an object I am getting. Now it's already been converted into the tensors. Now I am getting the torch tensor. Done with this? Okay. Now the task for you is moving back to this one. Right. Iterate through train data set to visualize the images. Let's iterate to the train data set to visualize the images. Fine? Okay? Let me. For I in range of length of this train data set okay, what you are getting? Individual image is to be taken. Image equal to train data set of this index I and the label equal to train data set of I, indexing I. Now I can get each individual images of the train data set. Across all the images in the train data set 26. Okay. Right? If I print this image dot shape, tuple object do not have the shape attribute, so leave it. Let me, what is my intention is visualization. Let me visualize first. So use the matplotlib library for visualizing. For this what I need first? Import matplotlib.pyplot as plt. Okay. Now plt.imshow of image, plt.title. I can get, okay, let me try individually, step by step. plt.imshow of image. What I got? See this error? Value error I am getting with one dimension. Let me check once again. Sorry. This is the wrong I made. Okay. Both the things I would get is train comma label. Sorry. It's a iterable tuple, right? Okay. Can you see this? Can you see the error? Not getting? Look at here. What you are doing? Across all the samples in the trained data set, you are iterating using the for loop. For I in range of length of trained data set, what is this trained data set of each individual consisting of? I had shown you na just before. It's a tuple, both image and a label. So it will return 2 tensors. When you access this, each sample of this trained data set, you will get 2 tensors. One is the image, second is the label. I am trying to visualize this image, plt.im show of this image. Okay. If I try this, I am getting this error, invalid shape. This is we discussed yesterday itself. What is the order it is specifying shape? 3, 28, 28. What is this 3? Channel. It should be at the last position for PLT. When you are rendering the images using IM show of the matplotlib, channel should be at the last index position. Now I need to reorder these indices for these torch tensors. When you use the tensors, torch channel information should come to the first index position. It should be reordered. For this, what is the method supposed to use? Permute for reordering. So when I am showing this image, rendering this image, calling this permute method by specifying the order of the dimensions, this height, width and channel. I shifted the channel at the 0th position of my image tensor to the last position. Done it? Can you see this, what I am getting? Transformed image I am getting. It is not visible for us, right? Because it is already transformed object. Then we will do one thing, it is just playing only. You just remove this part, do not apply these transformations, just playing. Let us play for some time. Do not apply the transformations. I just commented the transformations, applying the transformations, and run this code cell and run this one. As I do not apply the transformation, I do not want this permute supposed to be used. Can you see this? Now I understood how the animated images are. These are the animated images that we are having in our folder. Okay? But you are getting only one image, not all the images in the trained data set. Only the last images it is getting displayed. I want all the images to get displayed, correct? So, what I supposed to do it here? Within a grid, within the for loop, within a grid also I can do this one, right? PLT, PLT dot subplots, within the subplots I can do it. Within subplots, totally there are 26 images are there in my data set. So, let me divide into the 5 rows of 6 columns. Okay, 5 rows of 6 columns at the index position 1, done, and image, and I do not want these axes to get displayed. So, PLT dot axis is off. And I want the title also for this one, PLT dot title. What is the title? Of which class it belongs to? That images of which class? That is there in the label itself. From this label index, I need to get that class name. How can I get it? Dataset dot classes of that label. Can you see this? Now I got all the 26 images in 5 rows or 6 columns, 5 by 6, great. But clumsy is there. Let us fix the size of the figure. Okay. How can I fix this size? Here itself before the loop I can define the figure fig equal to plt dot figure of, different methods are there, whatever is you can use. I will tell you one at a, I cannot tell all this. Figure size equal to, what is the size, 12 by 12, let me take. Now it seems to be good, perfect way of visualization. Now just have a look on this data set, my train data set. You can see here these images wearing the glasses, animated faces wearing the glasses. You can see these are the 12, 13. First 13 images of glass category, next 13 images of no glass category, a total of 26 images are there in my train data set. Correct? So if I wanted to see in the test data set what are the changes supposed to be done, can you tell me? How many images are there in my test data set? Only 4, na? So grid is supposed to be specified, changed. Got it? 2 images of glasses and 2 images of non-glasses animated faces. I just removed that transformations applied. If you apply the transformations, what are the changes to be done? Once again do that. Here in this, permute is to be called up. That is only the difference, because being converted into the torch tensors, dimensions has been changed. So again reorder the dimension. Now these are the images I am getting, transformed images. How many of you reached to this point? I will wait for 2-3 minutes. Am I going fast? Huh? No, fine. We have a lot of concepts to learn. You need to do, speed up. Different techniques will be there. So what I did here, rendering the images from the training data set. There is one more concept you are going to learn. Everything is new. Do I need to wait for some more time? Guys, done with this? Okay. Let's back to the main code again. Just remove this printing the or comment it, no problem. So our intention is creating the data sets over. Is it sufficient? Is the data is ready? Have you prepared the data set for the machine learning algorithm? Can I apply some algorithm with this data? Is the data is ready for applying any algorithm? Anything left over? You just have seen by length of this trained and tested data set. What is the trained size? 26, because it is a simple one. If you are having lakhs of images, your trained data set should be lakhs of images. Will you pass this entire lakhs of images at a time image data to the model? What is to be done? Batching. Got the point? We need to divide, split the data into the batches, mini batches. We reach to the stage of creating the train and test data sets only, but still we have the step of dividing them into the mini batches. This is the concept of data loaders. In the Torch Vision library, there is a beautiful module data loaders which will help us for dividing the data sets into the mini batches. Okay. So, the next step would be, let me comment it, creating data loaders. Is it visible to you all? Creating data loaders. So, I need train data loader, I am taking it as a loader, and test loader. Two things I need. Okay. In order to create the data loaders, same is the library, instead of the subset, we are supposed to use the data loader object. So, take this torch dot utilities dot data dot data loader, D and L are capital. Train loader should be created from the train data set and test loader will be created from the test data set. So, pass the trained data set which is already been created in the previous step to the train loader. Similarly, do it for the test loader as well. Done with this? Okay. Run the code cell. It's running successfully, nothing is been shown. Okay, no problem. I need another code cell. How can I get it? Okay, if I zoom it, I can. Yeah. Have you created the data loaders? Done. Let us check how the data is there in the data loader. What is the job of data loaders? Okay, from the data sets we are creating that. I haven't defined any batch sizes. Let us see first. Right. In order to see how the data is, iterate through data loaders, train data loader. Okay. For data comma label in enumerate of data train loader, all are iterable variables. Okay. For data comma label, return the tuples. In enumerate of train loader, I am just trying to print the data shape data dot shape and printing label also. This is target. Input and target, nothing is there. Why to take data? Just to take it as data and label. Int object is not, it is returning one more thing, that is the batch index also. Okay, look at here. I will display the batch information also. Batch IDX. See what my data train loader is consisting of. Each individual sample is considered as a batch, so that you got the batch 0. What is the data? One image which is of 3 channel RGB and the size 28 by 28 and its corresponding label is 0, meaning glass category animated image face. Likewise, how many batches I got? 25 batches. because I am enumerating trained data set of 26 images, 0 to 25 I got. This is not the right way. I need, because here it is each image is considered as a batch. No, we have to define the batch size. Now let us do how I am doing this one. While defining the batches, look at here, creating the data loaders, along with passing the data set on which you want to create the data loader, now define the batch size by the variable batch underscore size equal to, I have very few images, 26 only, so I am taking the batch size is 5. Done. I am doing this for both the train and the test loaders, defining the batch size. Okay. Now let us see the result. How many batches would I get now? For 26 images, 5 batches, correct? Let us check. Am I correct? Done. Batch 0 to batch 5, sorry, 6 batches. 26 images, na? Batch size is 5 I defined. 5 5 is 25 plus 1. Last image will be into the another batch. 6 batches I will get. Look at now the data, how it is looking. What is this 5? Batch information. Batch size 5, 5 samples are there. Each image is a 3 channel color image and pixels are 28 by 28. Their corresponding target variables are all zeros, meaning that in the first batch all the images are one category, that is called glasses. Animated faces wearing glasses only. Am I correct? Look at the second batch. How the batch seems to be? Batch size 5 images. Each is of 3 channel, 28 by 28 pixels, and this one. And then this one. And then this one. Now tell me what is the problem with this. And the last batch. First 5 batches for 25 images is over. I left over with only one image is my train loader. That will be considered as the last batch. So look at the data shape 1. For the last batch only one image is left over. For the remaining batches you got the shape, first is the first dimension 5, that is the batch size. Okay, so corresponding label target is single element tensor. Fine, it is clear. Now what is the problem with this? Look at the target tensors, you can say, you can understand this. What is the problem of doing in such a way, of dividing the batches in such a way? Now my data is ready, no problem. Batches, mini batches, 5 batches of information is there with me. I can pass this data to my model. Right. First batch, one batch at a time will be used for training the model. The first batch is consisting of all the images of only one kind of category. In such case, what the model will learn? Correct? Because my data is organized in a sequential way, first no glasses and then glasses, 0, labeled 0 and 1. First all the first 5, the images are finished, then it will go to the next one. In such cases, model will not learn anything. What should I do? Shuffling. When you are creating the batches, shuffling of this data should be done. So I am introducing another variable when creating the data loaders, that is called shuffle equal to true. Understood? Shuffle equal to true. Do I need to specify the shuffle for the test loader? Not required. Test data set, test loader is only for evaluating the model, it is not required. When you are training the model only, data should be shuffled. Of course, if you are using as a pattern and habit of using the variable, but you should make it not necessary, you can make it as false. Done. Run this code cells again. Now you can see the effect of this one. Yes, I did perfect pre-processing of image data. Am I? Now tell me, how many of you understood after this session why you are doing all these steps, and who don't know before this session? I just wanted to know honestly and genuinely. Tell me, before this session, how many of you don't know why you are using and why are you doing all these steps? Can you raise up the hand? Before attending this session, how many of you don't know why you are using all these steps? Raise up the hands. After this session, you understood why you are doing all these steps? Thank you. Okay. Task for you. Simple task for you. Have you done up to this part? Done. Just before, I iterated through this trained data set and visualized the images. Now I am asking you, iterate through the trained loader and visualize the images. Iterate through the trained loader and visualize the images. What is the difference between iterate through the data set and iterate through the loader? Can anyone? When you iterate through the data set using the for loop, you are getting individual images. With slicing the sample of this data set, correct? But what about the loader? Look at the loader output. Batch of images. Loader is consisting of the images in terms of mini batches. You have to iterate and extract each batch of the loader and visualize. Got the difference? Fine? Okay. For loop you can use it however you are using like the data set. I am introducing another one, that is called extracting each batch manually. This trained data loader is already iterable. Now we need to convert into the iterator using iter method. So first this, so that I am creating data iterator by converting this iterable variable into iterator. I am creating the data iterator. Once the iterator is created, now I am going to fetch the next batch using the method next of this data iterate variable. Getting the point? Using for loop you can do it. For will automatically create the iterating. Will iterate this value and extract the information. If you wanted to extract each batch data manually, this is the method. First of all, you need to convert that data loader into iterable variable so that the data iterator has been created. Now call the next to get the next batch of information, so that what it is returning is two torch tensors. One is the images and second is the labels. It will return two tensors because this loader is consisting of the data in terms of batches. What is a batch? Consisting of list of images and corresponding labels. So when you call the data iterator with respect to the next batch of information will be fetched and it will return the tensors list of images and list of labels in that batch. Now you are able to display. So why you need to call this iterator manually? If you want the full control on the batch wise information, for example, if I ask you to display particular batch of images only, you need the full control. In such cases you have to call this next method and data iterator by manually, right? Now I got the list of images. Now the rest of the part is simple. For I in range of length of all these images. Now you can display this image equal to images of I one particular image and label equal to label of I, labels of I. Getting that? Now okay, you can display this information. Hopefully by copying I cannot try this one. Okay, let me try. I am show of image of permute access data lag. Fine. Got it? Some error I am getting. Okay. So I am using train loader. So grid dimension should be 5 rows of 6 images. Okay, got it? Too much of size is there. Let me fix the size of the image as well. This already done this part. I am just taking this one. Got it now? How many images I am getting? 5 images. Am I correct? Because I fetched only one batch from the train loader. Okay. This is up to handling bulk of images. This is how once you create the data loaders, data seems to be like this. Many batches of data has been created. Now the data is ready to feed it to the neural network. Right. Now you will be given an assignment. Pranay, will you share that assignment 2? Assignment 2. Fetch the notebook. PSEL CNN assignment 2. Based on the concepts whatever we discussed till now. There is an assignment. Okay. An assignment 2 is been opened. You have the 15 minutes of time. Do it. Whatever you did it in this live session, hands-on session, similar. Only a small change is there in that. Look at the assignment 2 which is given to you. Build a data pipeline for image classification task using the same data set whatever we discussed, glasses and no glasses, anim faces. But the thing is, your objective is loading the data set, pre-processing images and apply the necessary transformations and randomly split the data set into 80% for training and 20% for testing for each class. In the hands-on session we did it is 15 images of each class into train and the rest into test. What I am asking here, 80% of images of each class into training and the rest into the testing. Only the split logic you are supposed to define and change. Next, while creating the data loaders, I ask you to take the batch size is 6. Okay. Next, for visualizing the sample from the training data set, how I asked, and the steps is also provided to you. Use the image folder because your data is organized in such a way, folder and subfolders of each class. And for applying the transformations, 64 by 64 is the resize to be done and the grayscaling should be done. This is additional and converting into the tensors. Next is, okay. While splitting into 80% and 20%, use the random shuffling. Okay? Use the random dot shuffling. Meaning that once you created the class indices, use the random shuffling and take the 80% of samples into the trained data set and 20% in the test set. Okay. Now what else I asked? Visualize the second batch of training images from the loader. Okay. I told you how to fetch each batch manually. Creating data iterated through ITR method and then fetching the next batch information using next method or next function. Now I am asking you to fetch and visualize second batch of information into 2x3 grid. Fine. What is the constraint I made? Use the variable name TRANS for defining the transformations and the variable names train underscore dataset, test underscore dataset, train underscore loader and test underscore loader. That's it. Two exercises, graded exercises. First one is creating the pipeline. Second one is visualizing. Entire code you are supposed to do, including the importing the required libraries. Everything we did it in the hands-on session. You just refer back and do it. It will be practice for you. Only the change here is splitting into 80%, 20%. Instead of 13 images and it remaining into test. Just do it fast. All of you need to submit. Everyone has to submit. Pranay, let us see how many attempts are there. Logins 123, fine. You just have to refer the hands-on session, what we did till now, and write the code. It's already been 5 minutes over, 5 more minutes only. Nothing is difficult there. Make it fast. If you are facing any difficulty, I can help you. Any problem? Second iteration, right? Okay. Sorry, not second iteration. Second batch fetching. How can you get one batch? How can you fetch one batch? Next is the method. Okay. Just fetch and don't do anything. And fetch it again. What will happen? Got the point? So this is the reason why we are preparing the exercises. You should do that. If you attempt, you can understand what is the difficulties. In the hands-on session, I told you how to fetch the first batch. In the assignment, I ask you to fetch the second batch. It will be practice only. If you do the practice, you will be perfect. This is the reason why we are insisting and repeatedly telling you attempt and do the exercises. You think of it, how much time we are spending for making these exercises. All of you attempt the exercises. Done? Sorry? Are you struggling with solution? Anybody? So simple, man. In the first graded cell, what I am asking? Only this part. Splitting 80%, 20%. In the hands-on session, what I told? First 13 and next remaining. From the class indices, first 13 and the remaining into train and test sets. Okay? Instead of first 13, this 13 split point you are supposed to calculate. What is that split point? 80% of images from each label, each class. Already you got all the indices of each class into the class indices, one at a time. That 80% split point you are supposed to define. If you know the number of samples, it will be easy for you to capture the 80% of samples, right? Yes or no? 15 images are there in each class. What is the 80% of 15? Anybody? Huh? What is the 80% of 15? Amma? 12. Correct? 80% of 15. 15 8s 120. 12. 12 images of one category and 12 images of another category. It's so simple, na? That is one method. But actually that's not the right one. If you don't know the size of the samples, it should be counting the size of the samples and calculating the split point is important. So split point is 80%, 0.8. Split value is 0.8 is the split value. 0.8 times of length of this class indices will give you, correct? 0.8 times of length of this class indices every time will give you. So that is the first logic, and he already asked that question. Second batch of training images. I told you that. Next is the function or the method to call with respect to the data iterator to get first batch of information. To get the second batch of information, call again next without doing anything with the first. See, only 16 submission, among 16 only 8 are graded. What is this, guys? What are you doing? If you are really attempting, I am very happy. I can wait for time. Who is the Divya Bindu? You only? Okay, you are doing a mistake. Let me tell you. First code cell is for dividing the data set. Entire part should be there in the first code cell. You are doing that indices, slicing and data set creation, everything in the second graded cell. Grade cell 2 is only for visualization. Test cases were written accordingly. Take care. Just follow the instructions. First graded cell is for writing entire part of the creating the data set and data loaders. Second graded cell is ZR2 is for visualization only. Who is this guy? Uppala Manikanta. What you are trying to visualize? You are trying to save the image into the grid, that is train images.png. This PNG file, something you are doing. Yes, he is doing more experimentation than me. Mr. Deepak, you, fine, thank you. What is the mistake you did? I asked you to display the grayscale images, right? But you displayed the images in Viridis mode. Color map is Viridis. You changed it? Okay, let me refresh it. Right, score is done. Good. 26 graded. Only 43 submissions. What you people are doing the rest of? Okay, I waited a lot of time. You can do it afterwards also. Just one more small topic is there. Let me finish up as per the schedule. Guys, let us open another notebook that is there, shared with you. It's already been opened. PSEL CNN session 2 practice notebook. Keep open. It's enough if time. We have enough time to finish off the task. Keep this exercise aside. You can try it later. Let me finish off the scheduled task. Open another practice notebook titled CNN session 2 practice. Raise up the hands. Raise up the hand. How many of you opened this notebook? 1, 2, 3, 4, 5, 6, 7, 8, 9. Nice. PSEL CNN session 2 practice notebook. I'll take you to the next level. Okay? Right. Come with me. Look at here. Now the task is okay, good. This is the notebook provided to you. Now an image directory is been given to you. The name is anim faces 20. How it is organized? Bulk of images 1 to 20. Now the directory organization is different. Okay? Right. The task is create the train and test loaders with 15 images and 5 images into each from directory consisting of 20 images. Simple thing. How it is different from the previous data set and data directory? That was organized into subdirectories. That subdirectories are nothing but the class labels. Now this directory is simply bulk of images. Suppose if you are working with the concepts or the tasks like image generation using autoencoders or the GANs, you just need the bulk of images, no need of the labels and all these things, right? Of course, maybe also. Depends on the concept. So whatever it is, however the data is organized, accordingly we have to handle this data. That is the task. Now the directory is given to you is a bulk of 20 images. From this my task is, my intention is, I wanted to create train and test data sets with 15 images and 5 images. Fine. Right. Let us start with me. This is the image directory provided to you. Okay. Take the cell and this anim faces, this is the directory which we are taking. I am taking into the name. Okay, already it is been there. Okay. Anim faces 20. Done. Cannot access, so I have to specify this entire path. Yes, these are the 20 images which I am having. Right? Now I want to create the data set. I already told you how to do it using image folder. Can I use the same? Let us do. What is the first thing? From chart vision import what? Data sets. Now create the data set from this data sets dot image folder by passing this data directory which is the name anim is 20 faces or the complete path. Anim faces 20. What is the error I got? Could not find any class folder within that. What does it mean? Image folder was the library defined for handling the data directories which are organized into main folder and subfolders which are nothing but the class labels. Now my data directory anim faces 20 is not organized in such a way. Now tell me, can I use that image folder to handle this data? Got the point? Okay, I cannot use it. So what I supposed to do? If we have the image data of different architecture, You have to define your own customized data set to handle that directories. That is the concept of creating custom data sets. In order to create these custom data sets, actually the data sets will be represented in a torch in the library called dataset. This is the base class. This you can get it from the torch utilities dataset class. By inheriting this dataset class, we can create our own customized data sets. Following me? Let us start. So, if you are defining your own customized dataset class, obviously by inheriting another base class dataset, we need to override the methods. This you have seen in the deep learning session itself, right? The same I am going to tell you slowly, right? So, what are the methods? One is the constructor, which will be called up when you are instantiating the dataset class automatically. So, what is the responsibility of the constructor? Extracting all the images from the root directory which is specified. And then two more methods what we are rewriting is, one is the constructor by the init method, second is the length which returns the length of the images in your entire data set, and third is the get item. Three methods we are going to override. Let us start. Fine, start with me. So, what I am doing is, I am defining my own dataset class. The name what I am taking is anim dataset, which is inheriting the base class dataset. Where it is been defined? Torch utilities data.dataset. So, first of all, let me import that library. Import torch.utilities.dataset data.dataset. Done, imported. Then I am defining anim dataset class from the as a subset of the superclass dataset. Okay, how I am defining my class? By overriding those three methods. What is the first one? Constructor. I am defining the constructor method init, which takes the parameters. What is the, when you are overriding, defining any class by overriding the methods, what is the first parameter supposed to be passed? Instance variable. So, what is name by convention? What is name? Self. Okay. Now, what else? Root directory or the data directory you are supposed to pass. You are creating your own data set which will load the images from the root directory and apply the transformation whatever has been done by the built-in library image folder which we used in the earlier task. What you did there in the image folder, you just passed the root directory along with the transformations to be applied optionally, right? The same job, your customized data set to be done. In such a way I am defining it. Clear? So, what are the parameters for the constructor? This one, and the transformations. Transform equal to none, optional. I too making it as an optional. Okay? This is the method I am defining, right? What else to be imported here? Tell me. Self dot root directory equal to root directory then self dot transform equal to transform, whatever the transformations you want to apply, and then the next is the image files. One more is the image files. I want all those image files to be extracted into this one. Okay. How can I get all the images from this directory of the anion phases? Nothing but the root directory by listing. So, I am using os.list_dir of the self.root directory. Enough? So, as I am using OS, I am supposed to import OS library. Done. What my constructor is doing, understand? Transformations defining and the root directory path whatever you are passing, from that it is extracting all the image data. Done with this? Done. Then the next method to be overridden is length. What is the parameter? Instance variable self. Okay. How I am going to define? It just has to return length of what? Self.image files. All the image files has been extracted. This image files total length is to be returned. That's it. It is returning number of images that has been extracted from the root directory. Then the next method to be overwritten is get item. What is to be done here? Now let me ask you one question. In the very beginning, starting with a single image, how I explained that? Image from a path is readed using matplotlib library imread. Then what is done? Then what is done? Applied the transformations. Correct? Now in the image folder, did I read the image? No. Image folder itself read the image. In such a way it was defined. Now if you are defining your own data set, now the list dir is consisting of list of images only. You have to define reading that image. Correct? Thus reading of that particular image data is to be done and then apply the transformations whatever is. Okay. For this what I am using? So what it is returning, this get image parameters. Signature parameters will be, first is the instance variable, then this index. How these are defined is image, from this image files, here are the image files are there. Now from image files you need to extract one image at a time. It is a list image files of slicing. So image is equal to image self.image files of this IDX will give you one particular image. Now this image is to be opened, to be read. For this what I am using is the pill library. Okay. Image equal to, I am using the pill library image.open that particular, okay, let me very clear. This I am taking as image path. From this image path, however I had explained in the very basic concept with a single image, the same way I am taking you. So one image path is taken from the image files, that is into the image path variable. With respect to that image path, we are reading this image using the pill library image. As I am using pill library image, I have to import that. From pill import image. So now image.I is capital, image.open, I just read that image. Now image data is there in my variable. Next, for this image, transformations to be applied. Okay. I said it is optional. So if self.transform, then image should be self.transform of that image, transformed image. So you will get the transformed image. Done with this? Now the final image is to be returned. That's it. Transformed image is returned. Understood what are the methods overridden? This is the way of defining your own data sets. Okay, once done, then the next step is instantiating this data set. So I am creating the data set by instantiating my customized data set, ANIM data set, ANIME data set. Is it correct? ANIM data set. ANIM data set by passing this directory path. What is this directory path? The directory path what I am taking is this one. What is that? This one. This is the directory path. I said optional transformations. If I wanted to apply the transformation, first of all I need to define the transformations. Am I correct? So again is the same topic. Define transformations. How to define transformation? Trans equal to transforms dot compose of defining the list of transformations to be applied, transforms dot to tensor, this is one, then transforms dot resize, this is another one, whatever you wanted to apply. As I am using this transforms, I suppose to import transforms as well. Where do I import it? From torch vision import transforms. And I need the data loader as well, right? Along with the data set, I am importing data loader also. Transforms, okay. If there are any spelling mistake, take care of. Now when instantiating the data set from my customized data set, ANIM data set, I am passing these transformations also with the variable transform equal to trans, the transformations which I defined. Done with this, what is the next step? What is the next step? What I ask? From the entire data set, 15 images into train and 15 images into. I have my train size and test size, right? So splitting I am doing. What is my train size? 15. My test size equal to 5, and from this I wanted to create train data set, which is, I can use random splitting. I am introducing another one. Random split is the method. So if you are using random split, you are supposed to import it along with from say torch vision utilities, import random underscore split also, then call this, use this random split by passing what? Your data set which has been created along with the train and test indices together you can create. It will return two things. One is, another is the test data set as well. From the random split of train data set by passing train size comma test size. Okay. Train and test data sets has been created, right? Now what is the next step? Loaders. How to create loaders? Simple thing. Train loader equal to Already I defined this, imported the library data loader, fine. I am directly using this imported, right? Yes, already imported. So, directly I can use data loader of, what is that? From train data set I can create data loader of batch size equal to 15 images only I am having. Let me define it as the 3, and shuffle equal to, all these things already explained, I am not going to do, I am just using it. Then test loader, another is the test loader, data loader of test data set comma batch size equal to 3, and shuffling is not required. What is that? No module torch dot utilities dot data set dot, what happened? Okay, this data set is there. No module name. What is the error? Anybody? Sorry? From, right? From? No. What is the problem here? From import dataset, okay. But I am directly mentioning what is the problem. From torch dot utilities dot data import, okay, import dataset and data loader also, right? And random split also. Resize init is missing one required positional pair. Okay. While resizing transformation, I need to specify the dimensions, right? Very good. Okay, done. What else is there? Done with this. Over? Let me tell, you are not getting the exact data. Can anybody trace out? You are doing a mistake. Okay, simple thing. Iterate through this loader and display the data. Enough. Just to do single step so that you can understand the point is. Iterate through the loader. I will show you. It is a matter of 1 minute only. For images in, now tell me what is that. Just listen, tell me. Here the data loader is consisting of bulk of images. You just try to capture the difference between earlier and this one. Here the data loader, what is the returning when you enumerate this data loader, what it is going to return you. In the previous case of subfolders, when I iterate through the data loaders, 2 tensors it has returned me. What are those? One is the images, second is the labels. Do I get the labels here? That is what the difference. When you iterate through this data loader, you will get only the bulk of images. For images in length of train loader, you just print images dot shape, what you are, sorry, train loader. Int object is not iterable, you are not getting this. Enumerate across, correct? sorry, why I need to take this one? Directly I will take it. Images for, okay. Think I am, yes. Can you see this? This is what I am expecting you to find out. You just try this one. Images in train loader, print images dot shape. Already you got this torch tensors, right? What the error I am getting? I am not getting the shape of the images. What the error I am getting? No such file or directory. What does it mean? It is not able to access the image along with the path. Okay? You just recollect, go back when you are working with the image folders, you got these images along with the paths. Am I clear? Somewhere I had shown you accessing, yes, not here, somewhere I had shown you, you just try to recollect it. Sorry, that samples, if you look at this likewise. I think I disabled that point when you run this part. Yes, how you are getting? Entire image along with the path from the root directory. So when you are reading the image file, it should have to extract the images along with the paths together. That is what I am failing in this case. How can I do this one? Can you tell me, how can I do this one? This part, it's a simple step, you are supposed to do it. Show you a little bit wider, that is more detail I can show you that. I will finish off this one. So where is my data? In the data directory. Data directory or where? Okay. In the root directory, and the data directory is this one. I am missing this point. Yes, my data directory is anim faces. For I in os.listdir data directory, if I print this I, yes, what I wrote when I am loading the images in the constructor class, os.listdir of that root directory. If I use this, I will get only the images which are searched in the current directory, not from the root directory. So what I supposed to do instead of this, I have to assign or join the root directory path to this images. So what I am doing here is os.join, os.path.join or join.path, correct, path.join this anim faces root directory to this I. Just see what I would get. Now am I getting the complete path? So the change to be made there is this part. This part you are supposed to do it. Let us come back to this code cell where you are defining this constructor. Here you supposed to list this, sorry, already I wrote it here, this part I need. I will take it into the beginning portion. For my convenience, I will remove that once again. This part I supposed to list I for I in os.list of dir. What you supposed to do? with added information. os.path.join of this anim faces 20 to this I. Yes. Okay. Am I done correct? I am just listing. Something is missing, find it out. What I am listing? os.path of join of anim faces 20 with I. For I in os.list dir of this one, okay. Ending, I didn't close that list. Okay, done with this. Anim dataset object has no transform. Where I did the mistake, transform used. I used transform somewhere. Transform for fetching self dot transform. Okay. While defining the transformation, transform. Done. Now you got this. Now I created the data set and data loaders perfectly. The batch size defined was 3. Okay, 15 images were divided into 5 batches. Each batch size is 3 with 3 channel information of size 28 by 28. Got it? Yes, over. You just finish up this. Anybody got? Reach it to this point? Thank you. Understood this? So in today's session I covered 2 things. Handling the bulk of images or directory images which are properly organized and suitable for image folder library, and the second is which is not compatible to handle with the image folders, creating the customized data sets. 2 things. So I am stopping with this and finish up the second assignment. Any doubts in this? I think it is visible now, the full line of the code. Earlier we just accessed os.list.dir of that root directory, meaning that it is searching and extracting the images from the local directory. So the entire path is not given. But we need, when you are reading the images for processing, we need to read the images along with the root directory path. So what we are doing is, along with the images, okay. So one change I should be done. This is the anim faces shouldn't be used here. Self.root directory is supposed to be used here. Anim faces is a fixed name. Already we are passing with the name root directory. That's it. Tell me now, are the sessions are useful for you? Yes or no? Fine. Thank you. For today I am stopping these sessions. Thank you all.